People spend around $1 billion annually for the purchase of magnets used to treat a wide variety of pains. Researchers conducted a study to determine whether magnets are effective in treating back pain. Pain was measured using the visual analog scale, and the results given below are among the results obtained in the study. Assumed normality. Use a 0.05 significance level to test the claim that those treated with magnets have a greater mean reduction in pain than those given in a sham treatment, similar to a placebo. Does it appear that magnets are effective in treating back pain? Answer this by constructing a confidence interval. In this case, we are testing the claim whether the average reduction in pain in the magnet treatment subpopulation mu1 is greater or better than the average reduction in pain in the sham treatment. And so we are testing to see whether mu1 is greater than mu2. So this is the right tail test. With the right tail test, given that the significant level is 0.05, then we would construct 1 minus 2 times alpha, or 1 minus 2 times 0.05, which is a 90% confidence interval. Even though 1 minus alpha is 95%, but a confidence interval have the left tail and the right tail, and so if we want the right tail to be 0.05, then the left tail would need to be 0.05, and this is why this confidence interval is a 90% confidence interval instead of the 95 confidence interval. For the confidence interval for the two sample t-tests, we compute y1 bar minus y2 bar plus or minus the critical value t times the standard error, but the standard error is s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, where y1 bar is 0.49, y2 bar is 0.44, s sub 1 is 0.96, s sub 2 is 1.4, n sub 1 is 20, and n sub 2 is 20. And so we have y1 bar, y2 bar, s sub 1, n sub 1, s sub 2, n sub 2. We just need to find the critical value t. But to find the critical value t, we can use either the t-table or the t-calculator. Using a t-calculator, since the area on the right-hand side is 0.05, we're looking for the corresponding t so that p of x greater than whatever the t value is, it has to be 0.05, but also we would need to use the degree of freedom to be 19 because it is one less than the smaller sample size. In this case, both samples have the sample size of 20, so 20 minus 1 is 19. If one is smaller, we would use that smaller sample size, subtract 1 to get the degree of freedom. The calculator will give us the corresponding critical value t, and it is 1.729. This critical value not only depends on this significance level, but it also depends on the sample size or the degree of freedom. Now that we have every component in this formula, we can compute the confidence interval. The difference in the mean y sub 1 bar minus y sub 2 bar is 0.49 minus 0.44 or 0.05, and that is the number that would go here. y sub 1 bar minus y sub 2 bar. The critical value T star is 1.729, which we just computed, and that would go here. The standard error is the square root of s sub 1 squared, but s sub 1 is 0.96, and we square this divided by n sub 120 plus s sub 2 squared 1.4, so 1.4 squared is divided by 20, and plug this in a calculator with everything underneath the square root sign. We will get 0.376, where we round it to 3 decimal places. Now the difference in the mean is 0.05 plus or minus. The critical value T star is 1.729 times the standard error is 0.376. There are two computations here. 0.05 minus 1.729 times 0.376 is approximately negative 0.606, rounded to 1 decimal place, negative 0.6. And the other one is 0.05 plus 1.729 times 0.376, and this is 0.706, rounded to 1 decimal place, 0.7. And so we say that we are 90% confident that the true difference is between negative 0.6 and 0.7 in interval notation, or in inequality it is negative 0.6 less than mu1 minus mu2 less than 0.7. And for the two sample, we are very interested in whether 0 is in this interval. If 0 is in this interval, then we would fail to reject the null hypothesis, because the null hypothesis is the statement of indifference. Remember that the null hypothesis assumes that mu1 minus mu2 equals 0. And if 0 is in this interval, then we would support the null hypothesis. And so in this case, 0 is included in this interval. This means we fail to reject the null hypothesis because 0 is in it. And if we fail to reject the null hypothesis, then we would need to support it. Therefore, if we support the null hypothesis, then we would reject the alternative. But the alternative hypothesis is mu1 greater than mu2. And since we reject this, we reject the claim that magnet is effective. We say that magnet treatment is not effective.